In this video, we're going to take a look at solving problems involving random variables. Now, let's say we have two random variables. So let's say we've got x and y. Let's write these down to begin with. So I've got x, and we have y. And for y here, this random variable, let's say I can express this then as a function of the other random variable. So I can write this here as g of the random variable x. Okay. Now, if g is a one-to-one function, and we also know the mean and variance of y, then what we can do is go on to evaluate the mean and variance of x. Now, solving problems involving random variables is often the topic that students find the most challenging. So, to make this a little bit easier, what I'd recommend is that you're confident with two things in particular. One, I'd make sure that you're confident with the properties of discrete random variables such as linearity. So, for example, if I take the expectation of something, say, like the expectation of ax plus b. Okay, you should be familiar then that we can write this here as a times the expectation of x plus b. Okay, the expectation of a constant is just a constant, and then this expectation of this random variable x here times by a constant, say a, we can take the a out in front using linearity. So being confident with stuff like this makes solving problems involving random variables a lot easier. That's something to be aware of. Obviously, this applies to the variance as well. So, for example, if we're looking for the variance then of, say, ax plus b again, in this case, this would be a squared. That's by the variance of x. And we don't have anything to do with b here. The variance of a constant is just 0. Okay, so just being confident with these two properties here will make this topic and chapter a lot easier. The other thing to mention is when you're solving problems involving random variables, what you will often obtain is a system of linear equations. So being confident with matrices and inverse matrices will make this topic a lot easier. So those are the two things that I'd recommend. So what we're going to do now is just take a look at some practice questions here for solving problems involving random variables. Starting off then with question 1 here, we've got x as a discrete random variable. We're also been given the random variable y, and that's defined as y is equal to the random variable x plus 30, all divided by 20. Now we're also given the mean of y, the expectation of y here, that's equal to 5. And we're also given the variance of y, which is equal to 8. So to begin with here, we have to find the expectation of x. So for a then, this is for the expectation of x. Where do we begin? Well, the first thing that I should do here is take the random variable y. I'm going to rearrange this and start by making x the subject. Okay, this random variable x. So this should be hopefully nice and straightforward. To begin with, I'm going to times both sides by 20. So 20y is equal to x plus 30. And then finally subtract 30 off both sides. So what I get here is the random variable x is equal to 20y minus 30. Okay, so from here then, because we're looking for the expectation of x, this is my random variable x here. That's equal to 20 lots of the random variable y minus 30. If I take the expectation here of both sides, I'm going to get the expectation of x is equal to the expectation of 20y minus 30. So let's just write that down to begin with. The expectation of x here is equal to the expectation of 20y minus 30. Okay. And now this comes back to the point I made at the beginning of this video, basically about being confident with the properties of discrete random variables such as linearity, because we now need to apply linearity here. Okay. So we know that the expectation of y is 5. So let's just make a note of that here. The expectation of y is equal to 5. So in this case here then, I can bring this 20 out in front. So this is going to be equal then to 20 lots of the expectation of y. And then the expectation of minus 30, well, that would simply be minus 30. Remember, if you take the expectation of a constant, it's just equal to the constant itself. I've got 20 lots of the expectation of y minus 30. So the expectation of y is 5. So what I get here then is 20 times 5 minus 30. What I've got now is 100 minus 30, and that gives us 70 there. Okay, so there we have it. So that's the solution to part A. That's the expectation of x. Now the variance of x follows in largely the same way here. So for part B then, so this is now for the variance of x here. Like I said, it follows in largely the same pattern. So the expectation of x was the expectation of 20y minus 30. The same is true for the variance here, so it would now be the variance of x equal to the variance of 20y minus 30. The variance of 20y minus 30. And again, I'm just going to use the properties of linearity here. So now I can bring the 20 out in front, but remember when we pull this 20 out in front of this constant, I now need to square this constant here. It's now going to be 20 squared times the variance of y. And remember, the variance of a constant is just equal to 0. So all I've got here now is 20 squared times the variance of y. Well, the variance of y, we're given that at the beginning of the question, that is equal to 8. The variance of y is equal to 8 there. So 20 squared is 400. So I've got 400 times by 8. And that gives us 3,200 there. Okay, that's the solution to B there. And we're nearly done now. We've just got part C here. So for part C then, if we do this here in the bottom left, we're now looking for the expectation of x squared. So how would we do this in this case? Well, we're just going to simply use the formula then for the variance. So we've already calculated the variance here by using the properties of discrete random variables and linearity. However, don't forget the variance. I'll do this in the top right here. Don't forget that the variance of x here is given as the expectation of x squared minus the expectation of x all squared. Okay, like so. So what I can do now is just rearrange this so that the expectation of x squared is the subject. We already know the variance of x. We already know the expectation of x. So I've got everything I need here now to actually find the expectation of x squared. The expectation of x squared, just rearranging this formula here, making the expectation of x squared the subject, that would be the variance of x plus the expectation of x squared. If I write that down here, that would be the variance of x plus, I'll put it in brackets here as well, the expectation of x all squared. Okay. Well, the variance of x, that is 3,200. The expectation of x, that was 70. So I'm now going to add 70 squared here. And then I'll just put this into my calculator here. What I get then for 3,200 plus 70 squared is 8,100 there. Okay. And there we have it. So always keep an eye open for this here. If you have to find the expectation of x squared, you can usually just find that by rearranging the formula here for the variance of x. Okay. And there we have it. So that's the solution there to question 1. Then look now at the very last question here, question 2, where we've got the discrete random variable x, which has the following probability distribution. And we can see that here in the form of this table. And we're also told that the random variable y is defined as y being equal to the random variable x plus 2. We're also given the expectation of y is 2.8, and this probability here that y is less than or equal to 2 being equal to 0.35. So using all of this information here, we need to write down 3 simultaneous equations in terms of A, B, and C. So this is quite a tricky question, and there's quite a few parts to this. So hopefully I'm going to break this down step by step and show you that it's not quite as challenging as it looks at first glance. There is just a few different parts you need to be able to break down here. So what I need to do basically is use this probability distribution here and these given bits of information to obtain my 3 simultaneous equations. So the first equation is definitely the easiest to obtain. And my first equation, so this is for part A, we obtain the first equation by using the fact that the sum of these probabilities here must equal 1. So the sum of these probabilities here must be equal to 1. Okay. So in other words, A plus B plus C plus B must be equal to 1. So A plus B plus C plus B must all equal 1. And I can even simplify this here to give us our first equation. So A plus 2B plus C is equal to 1. Okay, and that is equation 1 there. That is equation 1. Like you can see, that one is quite nice and straightforward. The next two aren't as straightforward, but we will break those down. And like you can see, they're not too bad once we get there. So that's equation 1. Let's take a look now at equation 2. And equation 2 we're going to obtain by using this fact here, that the expectation of y is equal to 2.8. Now, the random variable y is defined as y being equal to x plus 2. Like we saw for the previous question, where we rearranged and made the random variable x a subject, I'm going to do the same here. Okay, so if y is equal to x plus 2, if I rearrange this and make x a subject, then we can see that the random variable x is equal to y minus 2. Okay, so I want the expectation of x here. Okay, so I'm now going to take the expectation of both sides here. The expectation of x is equal to the expectation of y minus 2. Like so. So from here now, we now need to use the properties of discrete random variables and linearity. So I can write this here as the expectation of y minus 2, because remember, you take the expectation of a constant, it's just equal to the constant itself. And we know the expectation of y, that's 2.8, so therefore the expectation of x that's going to be equal to 2.8 minus 2. Just replacing the expectation of y there with 2.8. And if we evaluate this here, this gives us 0.8. Okay. Now, obviously, this isn't an equation in terms of a, b, and c. So we don't have equation 2 just yet, but we're nearly there. So now, if I just refer back to my probability distribution here, we know that we can find the expectation of x by taking the x values here and multiplying those by their respective probabilities and summing those up. So for example then, if I do it over here, expectation of x, that would be equal then to minus 1 times a plus 0 times b plus 1 times c plus 2 times b. So if we evaluate that here, minus 1 times a, we've got 0 times b, which obviously would just be 0, but if I just include it anyway, we can see it in full. I've then got 1 times c, and then finally 2 times b. And we know all of this here is equal to 0.8. Okay, and if I evaluate this here, just simplify each bracket, I get minus a, 0, c, and 2b. So minus a, I've got 2b, and then finally c there. We know all of that is equal to 0.8. Okay, and that actually gives us equation 2 there. So that is equation 2. So all we need now is our final equation here, and then we've done part A. So my final equation here comes from this fact here, that the probability of y being less than or equal to 2 is equal to 0.35. Now to find this probability here, I need to actually get the probability distribution of y. This is the probability distribution of x. I now need the probability distribution of y. So all we need to do is just write down the table here. So let me just do that underneath here. So I've got y. We've got our probabilities here. It doesn't need to be particularly neat, just so we can see what we're working with. Like so. So now for the inputs here of our random variable y, we obtain those using the definition here of y. So y is equal to x plus 2. So x takes these values here, minus 1, 0, 1, and 2. So for example, my first input here for y, well, that would be minus 1 plus 2, which would give us positive 1 there. Okay, so my first input for y is 1. My next value then, or my next input for y, that would come from when x is 0. It would be 0 plus 2, giving us 2. And now you can see it's just going to keep increasing by 1. So I've got 2 next, then we'll get 3. We'll get 3, and then finally we're going to get 4 here. Now you can see my table is not neat at all. Do use a ruler when you're doing this. I'm doing it freehand. But that's our table there. And the probabilities will match accordingly. Okay, so A, B, C, B, it'll be the exact same for this probability distribution here as well. So I've got A, B, C, and B there. Okay. Now for the probability that y being less than or equal to 2, using our probability distribution here, in this case, those two values would be y equals 1 and y equals 2. So that's probably that y is equal to 1. And the probability of y being equal to 2. Okay. So from here now, we know the probability of y being equal to 1 plus probability of y being equal to 2 satisfies this probability here, which means my two values then would be a and b. So that's going to be a plus b. And we know the probability that y being less than or equal to 2 is equal to 0.35. So that gives our final equation here. That means that a plus b must be equal to 0.35. And that actually gives us our three equations then. So that's equation 3. All I'm going to do here to finish with is just write this down now as a system of linear equations. I'll do it in red. You can kind of see this clearly. In fact, let me do it in orange. So what I've got here is my three equations. So I've got equation 1, so that's a plus 2b plus c equals 1. A plus 2b plus c equals 1. And then got equation 2, so minus a plus 2b plus c equals 0.8. And then finally equation 3 here, a plus b equals 0.35. A plus b is equal to 0.35 there. Okay. And there we have it. So that's the solution to part A. So what I'm going to do now is clear the screen. So just make a note of what we've got here in orange. We do need that to answer part B. So let's just clear the screen here and go ahead and answer in part B. So for part B here then, we now need to solve the system of equations to find the values of A, B, and C. So let's just make a note of the system of equations again. So we had equation 1, so it was, where did I write that down? So I've got A plus 2b plus c equals 1. I had equation 2, that was minus a plus 2b plus c, and that is equal to 0.8. And then finally, our last equation was a plus b is equal to 0.35. Okay. So from here, what I'm going to do is use this system of equations and solve for a, b, and c. And the way that I can do that is by using a matrix equation. Okay, so using matrices here, what I'm going to do is write this now as, so this a, 2b, and c, I'm going to write that as 1, 2, 1. And then I'm going to times that by the matrix of a, b, c. So what I mean by that is, let me write this down in 4. So I've got 1, 2, 1. That's my first row here in my 3 by 3 matrix. And then we're going to multiply this here by a, b, c. Okay. My next row here would be equation 2. So that would be minus 1, 2, 1. And then finally, my last row here would be 1, 1, 0. Okay, we don't have any c values, so that's just 0. I've got 1, 1, 0 there. And the product of these two matrices here, that must be equal to 1, 0.8, and 0.35. Okay. Like so. Now from here, you can do this by hand, but I wouldn't recommend it. The idea that the examiners are looking for is that you use your calculator. So in this case here, for this matrix of A, B, C, what I need to do then, therefore A, B, C, that is given by taking this matrix here and finding the inverse and times it by this matrix here. What I'm going to get then is 1, 2, 1, minus 1, 2, 1, 1, 1, 0. This matrix here, like I said, I need the inverse of that, so clearly that isn't the inverse. I'm going to put that into my calculator in a moment, and I'm going to times that here by 1, 0.8, and 0.35. Like so. And all you need to do now is just put this into your calculator here. So input this matrix here, this 3x3 matrix, input this matrix, and take this matrix here, take its inverse, and then times it by this matrix here. And this will give you the values of A, B, and C. So therefore, A, B, C is going to be equal, that is 0.1, 0.25, and 0.4. And that's if you do that correctly. Okay, so in other words, A is equal to 0.1, B is equal to 0.25, and C is equal to 0.4. Okay, and there we have it. So that gives the solution to B there, and that actually gives the solution to the very last question. Like you can see, it is a bit of a tricky question. There is a few little tricks you've got to be careful of. But for part B, do definitely use your calculator. It'll take you a lot longer to do that by hand. But there we have it. So that brings the end of this video on solving problems involving random variables.